Hey guys, thanks for stopping by. In today's video, we'll look at this DeWalt EV SAE. This is a level 1 and level 2 charger, but limited to 16 amperes. You can connect it to a 240 volts 6-20 NEMA 6-20 connector socket taken from your dryer or your cooking range. So 16 amps is really convenient that way because this is a portable one. This is supposed to be a portable charger, although this is a glorified extension cable, as many of you know, but still they call it as a charger. This is the EV SAE, which is the electric vehicle supply equipment from DeWalt. This is a little expensive compared to some of the others that are much cheaper, but this is a DeWalt, so the brand name and the build quality is good. For the sake of convenience, I would say lack of any other better term, we'll call this as the nozzle. That's what everybody calls. And I have just inserted pogo pins here because these holes are very tiny. So this is pin 1, 2, 3 and 4 and 5. So that is how the numbering system is. So this is the protective earth. So it's a very simple thing. And then we also have this, once you insert it into the EV, this locks in place. And when you're pulling it out, when you press this, it senses that this is going to get disconnected. And so the power stops. The relays in this will stop because the EV sends a signal to this one. So that is how it works. And I will add the clip that shows the resistance measurements on this particular pin, which essentially is connected to this one. This comes with a NEMA 620 plug. This is for 240 volts. But then you can use, they have also supplied this adapter cable which accepts NEMA 620 and goes into the regular 5-15, NEMA 515 regular household lighting circuit socket, 120 volts AC. Now, to make the measurements, it is convenient to simulate the presence of an electric vehicle, and I have wired everything on a breadboard here, as you can see. This red wire comes from pin number 5 of the J1772 nozzle, which is the control pilot. This is essentially a post-insertion signaling line, and that comes here. And from there you can use any small signal diode. So I have used I think this is a 4148 small signal diode, and the positive goes to this one, and from there it goes to this main switch here. I know it's a little clumsy here. So once I press this switch, the EV SAE, that is this unit, which is essentially not a charger, it is just a glorified extension, power extension, which has a relay, 2 relays in fact, and 2 or 3 current sensors, 2 used for GFCI and 1 for the actual current measurement, and a few other protective things. So this, when I press, it sends a signal to this unit saying that there is an EV present, and you'll see that the ready signal goes on, and now you're seeing green light here because it is connected to 240 volts. And this in this unit, when it is green, it is 240, and when it is blue, it is 120, as you have seen in some of the other clips. So once I press this, the ready signal will go on, as you can see now. That means, yes, there is the presence of an EV connected, but it still does not enable charging, because once I enable this one, within a few seconds, this unit sends a signal, pulse width modulated signal, to the EV, to the car, saying that I am capable of giving so much current for charging. So it sends a pulse width modulation. You'll see that in a video clip now. And once that comes, it enables, that means this switch actually is simulating a relay inside the vehicle which gets enabled once the connection is established and once it receives the PWM signal. And once that goes out to this one, then you'll see that the charge LED lights up there. So in this I'm going to simulate that. So ready, and then once I do that, you can hear the relays clicking, and now it is supposed to be charging. So that is how it works. It's a very simple circuit. So again, so this comes from pin number 5, and this is the protective earth, which is pin number 3. Protective earth comes here, and from 5 it goes through a diode through the main switch, and then from there actually it is connected to 2.74 kilo ohm resistor. In this case I think it is a 2.7 kilo ohm resistor, and that connects to ground. That means once we press the switch, so this 2.7K comes between pin number 5 and the protective earth. And once I enable this one, this switch actually connects to a 1.3 kilo ohm resistor. In this case I did not have a 1.3, I've just used a 1 kilo ohm resistor, but it works, and that is again connected to ground. So naturally the vehicle will be checking the voltage drops across the terminal after the diode. So that is how it works. It's a very simple circuit. And again, once I enable this one, the ready will go on, and once I enable this, the charging starts. So that is how it works. And with regards to pin number 4 connection, I'll introduce a clip here which will show you the actual measurement of the proximity sensor. What are the resistance values and what are the voltages required there for this unit, EVSE unit, to sense the presence of a vehicle EV connected. For convenience, I am just using a transformer here which gives different voltages, and currently connected to 240, and when I want to test it on 120, I just move the plug here and test it on 120. So this is just for convenience to simulate different voltage levels. I know this is a little messy here. You'll see that this is pin number 1, the top one, and this is pin number 2. So this will be line if you are using 120 volts, and this will be neutral. But if you are using 240 volts, this also will be the next hot line. So hot, and then this is ground, protective earth, pin number 3, and this will be pin number 5, the post detection, and this is the proximity detection, pin number 4, which is now not connected, which is not required at this time. All we need is pin number 5 and the ground. And I am not connecting any load at this time to keep the test simple. And all these wires here, one goes to the oscilloscope and one goes to the multimeter and one goes to the breadboard. And likewise here 3 connections, one to the multimeter, one to the oscilloscope, and one to the breadboard. So those are the connections, and I have just put some pogo pins. In this test we will check the resistance between the PP, the proximity pilot pin, and the earth, and I am just using a pogo pin for connection. So when the latch is closed, it is 150.8 ohms, and when it is open, it is 482.5 ohms. When the EVSE is connected to 120 volts, the power LED is blue, and then it goes into ready and then the charge mode. Now here we are measuring with the oscilloscope the pulse width modulated value. It comes to around, as you can see here, 18.5%. 18.5% is the duty cycle, and that equates to about 11.1 ampere. and I'm doing it a couple of times to see if it is repeatable. Here I have connected it to 240 volts AC supply. You can see the ready and charge signals lighting up. And on the oscilloscope, again we are measuring the duty cycle. And you can see here it is at 25.7%, which equates to about 15.42 amperes. So this concludes today's test. Thanks for watching.